you guys. Today we're going to be learning about solving more equations, but this time we're going to be using multiplicative inverses. And remember, multiplicative inverse, another name for that is a reciprocal. Okay, remember from the other day that reciprocals, when you multiply them together, they should equal 1. So if I had negative 4/11ths, the reciprocal of that, you'd have to multiply to get 1. Well, what would that have to be? Well, it'd have to be another negative, and then reciprocal, you flip the fraction, so it would be 11/4. Negative times a negative is a positive. You get 44/44, which is 1. Okay, so we're going to solve and check. The first one we're going to look at is 6/11ths x equals 18. Okay, now technically, remember when we learned how to solve equations, we would put our wall up. If they're multiplying these together, we would divide both sides, and you don't have to write this part down right now, but we divide both sides by 6/11ths. Well, how do we end up actually taking 18/1 divided by 6/11ths? We would have to multiply by 11/6. So rather than doing all that work, okay, so if we know we end up having to multiply both sides by the reciprocal, let's just start with doing that. Okay, so this is the really cool thing, is that whenever you have a fraction times the variable, the easiest way to cancel them out is to multiply by the reciprocal. So what I'm going to do is I'm going to come out here and I'm going to multiply both sides by the reciprocal, which is 11/6. So I'm going to come over here and take 11/6, multiply it by 18/1. And check this out, you guys. This 11 cancels with that 11, 1 and 1. That 6 cancels with that 6, that's a 1 and 1. We're left with 1x, which is the same as x, right, because of our identity. And then we just have to work with this side. Makes it a lot easier. I'm going to cancel. That's a 1, that's a 3. And I get 33/1, which is 33. And again, how do I know if I'm right? You got it. We got to check it. So I'm going to go into the original problem. 6/11 times 33/1. Okay, I want it to equal 18. 11 goes into 33 3 times. 6 times 3 is 18/1, which is 18. And that's what we wanted, and it checks. Okay. Well, let's look at number 2. Number 2 looks like this. It's negative 7/13 x equals 28. And again, we know that these two are being multiplied together. We would have to divide, but to make our life a lot easier, we're going to multiply both sides by the reciprocal of negative 7/13. So I'm going to multiply both sides by negative 13/7. Multiply by negative 13/7. Negative times a negative is positive. They cancel. 13 and 13, that's 1. We get 1x again, which is x. I'm going to come over to the other side and take 28/1. And 7 goes into 28 4 times. And then 4 times 13, we're going to get 52, and we got to make it negative. So our answer should be negative 52. Well, let's check it. So in our check, we're going to write negative 7/13 times negative 52/1. Okay, well, negative times a negative, those become a positive. 13 goes into 52 4 times. So 7 times 4 is 28. And is that what we wanted? Sure is, and it checks. All right, number 3. This is where it gets a little bit more difficult, and I'm going to show you 2 different ways to do this. Okay, so negative 7/12 x plus 3/4 equals 1/2. Now you notice on this problem, we got a lot of fractions, and I know you guys don't really like fractions, even though fractions are our friends. Okay, so we could start off, if we wanted to, by subtracting 3/4 on both sides. Okay, we're left with negative 7/12 x equals Okay, so this is really 2/4 minus 3/4. Oh, we got to take 3/4 minus 2/4, which would be 1/4, and make it negative 1/4. Right? And here, we're multiplying negative 7 over 12 times x. So what I'm going to do is multiply by the reciprocal and multiply by negative 12 over 7 on both sides. Okay, well look, these all cancel out. I'm left with x equals negative times a negative is a positive. 4 goes into 12, and that's going to be a 1, that's going to be a 3, and I get the answer 3/7. Okay? Now that's pretty easy for me because I love fractions, and I know you guys do too. But I want to show you another way. Okay? So I have the original problem as negative 7 over 12 x plus 3/4 equals 1/2. I am going to multiply the entire problem in both sides by the least common denominator of 12, 4, and 2. What it would be the least common denominator, and it really doesn't even matter if it's the least common denominator, any common denominator. I'm going to use 12, so I'm going to multiply both sides by 12, and we have to use our distributive property here. We're going to take, that's 12 over 1, right? The 12s are going to cancel here, and I'd have 1 there. 1 times negative 7, that would be negative 7x. Plus, I got to take 12 times this. That's going to cancel this 4 out, and this is going to become a 3, right? 3 times 3 is going to be 9 equals, now I got to multiply the other side. 12 over 1 times 1/2, that's going to be 6. So, what do? I'm going to subtract 9 on both sides. And I get negative 7x equals negative 3. Divide both sides by negative 7. And I get x is equal to 3/7. Either way, you get the same answer. And I don't care which way you like to do it. It's an option. So if it says solve by clearing fractions and you like to use fractions, do it that way. Our check would be negative 7 over 12 times 3/7 plus 3/4. I want to know, is that really equal to 1/2? Well, we got to multiply first. Okay, those cancel. That's a 1, that's a 1, that's a 1, that's a 4. So I get negative 1/4 plus 3/4. I get 2/4. Oh my, look at that. 2/4 is really 1/2, so it checks. Okay? There's another one. Let's try this one. Negative 3/4 x plus 3/8 equals 27 over 32. I want you to try this one and bring it back to class, completed and checked. All right, so we're going to do number 5. It's negative 5 over 48 equals negative 5/6 plus 5 over 16x. Okay? Well, let's try the new method here. Okay? What is the least common denominator between 48, 16, and 6? Let's see. Let's look at the multiples. 16 times 1 is 16, 16 times 2 is 32, 16 times 3 is 48. Okay, so that one works. And we do know 6 times 8 is 48. So I'm going to multiply this whole thing by 48, and I've got to distribute. So I'm going to go to the front. Those 48s are going to cancel, leaving me with negative 5 equals, okay, 6 goes into 48 8 times. So I take negative 5 times 8, which is negative 40. Plus 8 times 5/16 x. 16 is going to go into 48 3 times. So 3 times 5x is 15x. Doesn't that look like a way easier problem to solve? It sure does, Mrs. Bowen. But Mrs. Bowen, I like to do fractions. It's okay. You can do fractions. Okay, so we're going to get rid of the negative 40. We're going to add 40 to both sides. And we get 35 is equal to 15x. Divide both sides by 15. And again, you guys, I told you could leave it as a reduced improper fraction. So 5 comes out of each of these. And we get 7/3. Okay? And you can plug it in to check it. But you got to go back up into the original problem. Okay, that's the only way you're going to know if it's right or not. So negative 5/48, is that really equal to negative 5/6 plus 5/16 times 7/3? Alrighty, so nothing cancels here. We're going to get 35 over what? That's 48. Plus, I'm going to change this to 48. So I'm going to take that times 8, and I get negative 40/48. Okay, when I really subtract those, I get negative 5/48. And is that what I wanted? It sure is, and it checks. How awesome is that? All right, the last problem that we're going to look at is a story problem. It says the height of a certain Norway spruce, which is a tree, like a Christmas tree, is 10 feet. If the tree grows 2.5 feet per year, find how long it will take the tree to reach a height of 25 feet. Okay, so remember, the first thing that we have to do is define our variable. What are they wanting you to find? So we're going to say I'm going to use t equal, well, what are they asking you? How long it will take, the time it will take to reach its height? To reach 25 feet. Okay? If you look at this problem, 2.5 feet per year, that's called a unit rate, remember? A unit rate. But what do we already know about this tree? Okay, we're going to write an equation now. We already know that the tree is 10 feet tall. But it's growing, and in math, it means growing is adding on to it. 2.5 feet per year. I'm going to make this into a decimal. If it was 3 years, you'd take 2.5 times 3. If it was 5 years, you'd do 2.5 times 5. We're going to use 2.5 times t. So 2.5 t, and we want to know when is it going to equal 25 feet. That's all there is to it. Well, this one, if we didn't want to deal with a decimal, we want this decimal to move one place over to become a whole number. What I can do is multiply the whole thing by, what would make it move over one place? Multiplying everything by 10. So I'm going to distribute. That's 100 plus, that's 25t equals, that's 250. Way easier to solve now. Subtract 100 on both sides, and we get 25t equals 150. Then we're going to divide by 25 on both sides. And that's easy because how many quarters are there in $1.50? So we're going to get t is going to equal 6 years. Easy enough, isn't it? Okay, now I want to ask you. Student 1 said this. I saw my math teacher with a piece of graph paper yesterday. Student 1 said that. You know what student 2 said? Student 2 said she must be plotting something. Oh my goodness, plotting something on a piece of graph paper. I cracked myself up. Have a good day.